Hey guys, Jordan here with VFX Vault again, and today we're doing another UEFN tutorial. Today we're going to be going over how to create a waypoint system. You see here we've got this little arrow attached to our character. As we move around, the arrow points towards the first waypoint that we've set. And as we move towards the waypoint, once we reach the waypoint, it'll point to the next waypoint in the system. So we can move to the next waypoint. And it's going to point again, it's going to change again to the next waypoint. We'll run over there. And again, we've reached the waypoint, so it's going to point us to the next waypoint. So in this tutorial, we're going to go over how to create these little waypoint beacons. We're going to create the little arrow that's attached to our character, and we're going to go over how to set it up in Verse so that we can reach each waypoint, move to the next waypoint, how to attach the arrow to the character, and how to keep it updated and pointing to the right waypoints. So let's get into it. So we're coming into an almost blank level. We don't need any of this stuff. This is from the previous tutorial, but in this first part, we're just going to go over importing the meshes, setting up the materials, and setting up the arrow mesh for our character. So we've made a new file, a new folder here, meshes, and I've got a small arrow mesh and a cylinder mesh I'm just going to bring in. So we just import, and you see we've got our small little arrow mesh here. It's just a mesh that we've kind of offset from the pivot down the, we want to make sure we have it facing down the x-axis so it's easy to rotate. And again, a cylinder mesh. Doesn't really matter how big it is, but it's a cylinder mesh that has no caps, nothing on the top or the bottom. If you want to get a copy of these meshes, feel free to join the Discord. I've put the link below in the description. We'll be posting tutorials most weeks, and I'll also be posting the content from the tutorials for free for anyone to download and use in their projects or wherever they want to use them. If you've got any questions, any comments, any suggestions about tutorials you might like to see next, or you run into any issues, feel free to join and just ask me if you get stuck. So next we're going to move on to setting up the materials. First, we're going to get into making the material for the beacon, for the waypoint. We come to make a new material, and we'll just call it m_waypoint. Open that up. Now, it's pretty straightforward. We want to use a bounding box. So if we right click and preview a bounding box here, we'll see what it does. So it's a little difficult at first to understand what it does, but imagine that it's giving us a gradient in 3 dimensions. We can pick out each axis to see exactly what it does in each axis. So along the red channel or the x-axis, we can see at 0 to 1 across our object's bounds. It goes from 0 to 1 across our object's bounds. So imagine around every object there's a box, a bounding box, and we go from 0 to 1 in that box around our object. So if we change it to a sphere, same thing, 0 here and 1 on this side of the sphere. And if we can change and check the other axis, so in the green channel you can see along the green axis here 0 and 1, or the Z axis, which is what we're going to use, we have 0 and 1. So we take this bounding box and we 1 minus, which is going to invert it. So instead of 0 at the bottom, it's going to put 0 at the top and 1 at the bottom. So if we just quickly plug that into our base color and we save, and then we drag this material onto our beacon, you can see now it gives us a nice gradient all around our beacon. 0 at the top, 1 at the bottom. And we can use this to make a nice gradient. So we've got that nice kind of glow, soft glow on our beacon. So if we multiply here, and we can right click, convert this to a parameter, and we can go color, oops, sorry, go here, go color, plug that in, let's make it a nice sort of light blue color, and we can turn it up a bit, set it to 5, just so it's kind of bright, and then we can go two-sided, so that if we come back in here we can see both sides on the inside faces, and we can also change it to additive so that it's translucent. We plug this into base color, and then we also plug this into, plug this into emissive as well. We can make it unlit because it doesn't really need to be lit. And then we plug the bounding box, the inverted bounding box, into opacity. We save that. If we come look at it in the level, it's got a pretty simple beacon, but there's a few things kind of wrong with it. First off, it's got this really harsh line where it intersects with the ground here. You can see it's this really harsh line, and then on the sides as well, it's got this harsh line where we're looking at the edge of the boundary, or sorry, the edge of the mesh. It's got this really hard line, so we can do some things to fix that and make it look a lot softer and a lot nicer. So first, let's get a depth fade node, and we can set the fade distance to, say, maybe 150, and you can play with these values if you want to. So we plug in the 1-, and we plug that into our opacity, and now if we save that, you'll see where our mesh is intersecting with the ground, or intersecting with any geometry now, it's soft. So if we change the fade distance back down to 0 and just quickly save that, so you see now it's got this really hard intersection, but if we turn it back up to 150, just save again, it's got this really nice soft sort of edge that blends nicely into other objects. So that's the first part, getting that soft intersection where it meets and intersects with other geometry. Now the next part is, how do we get rid of this bit on the side, this really harsh line on the side of the cylinder, so we can make it look a lot softer. So we have this useful node called axis aligned Fresnel. So if you don't know about Fresnels, don't worry. All it does is sort of, depending on the shapes of the objects that we have, it can make things sort of softer on one side and glow on the other side, or depending on how we're looking at an object, it can fade the edges. So we have a regular Fresnel, and if we just multiply the output to take a look, you can see it gives us, on some shapes it'll give us this nice glow, and then it's a bit darker in the center, and we can change the exponent, basically, you know, how bright or how dark should the middle be. So if we change it up to sort of 50, or how wide is the sort of gradient on the edge for the exponent. But with an axis aligned Fresnel, what this helps us do is it's much more useful for things like a cylinder. So if you don't fully understand that, that's okay. Just know that it's going to help us sort of soften the edges here on our axis, on our cylinder. So what we can do is we go multiply, and then we multiply this against our depth fade. So it's in between our 1- and our depth fade now. And then we need to plug in an axis. So which direction do we want our fade to sort of be pointing? So we want it to be pointing up. So up in the Z, so it's just a normalized axis here, pointing up 1 in the Z. Z axis up, so if we preview this and plug this in, and we can preview it on a cylinder in here. So you can see it's a little hard to see in the viewport. I'll make it a bit bigger here. You can see on the sides of our mesh it's starting to get a little darker, and then it should be sort of bright in the middle. So with the exponent, we can set the exponent to maybe 1.5, so we'll change this parameter to exponent. And again, you can play with these values if you want, see how it looks. I encourage experimenting to really understand a bit more what it's doing. So if we delete this multiply now, and if we save that, and you'll see now it's a little softer on the edge. We don't have the super hard edge where it sort of falls off, and we can turn this value up and down a bit more to get it a bit more softer. So if we sort of double it, now it's really soft on the edge, but we want to keep a little bit of that definition. So we can go say 1.5 I think is good. So we've got the soft edge, so it's not the sort of hard cylinder anymore. It's this nice kind of soft glow. So the last thing we want to do is, so imagine our player is sort of walking towards it, and then bam, they just kind of hit it and they go through it, and it looks a bit weird. It turns the whole screen blue. What we can do is to make the transition as we approach it a bit softer, we can use a camera depth fade. So we can fade this mesh, this material, based on how close our camera is to the mesh. So we drag, let's just make a little bit more space on our graph and put in another multiply. And then we go camera depth fade. So again, creates a gradient. Remember, we were using gradients here on our bounding box. Creates a gradient of 0 near the camera to white at fade length, useful for preventing particles from camera clipping. So we don't really need it for particles, but we do need it for this mesh. So we can set our fade length to maybe some values that I had before when I was testing. Let's go 2000. So now at a distance of 2000 units, so you can imagine we're drawing a line from where our camera is to where the side of the cylinder is. At a distance of 2000 units, there won't be any fade. And then as we move towards it, it'll fade down to 0. So, you know, as that distance closes between 2000 units and 0 units to our cylinder, it's going to fade the cylinder out a little bit. So if we just plug that in and save that, now you can see as we move towards our cylinder, fades out. So the fade is a bit strong at the moment, so what we can do is we can offset the fade a little bit. So imagine again, we've got our distance from our camera to the edge of our cylinder. We can push that distance or pull it towards the camera based on our offset. So put another value in, and just a value I found before that worked. It's 500. Again, play around with these values, see what they do when they change them so you get a better understanding. But we'll just save this for now and offset. See now, sort of as we approach it, it's going to fade off a lot sooner. So at 500 units away, it's completely faded. And then as we move out to sort of 2500 units, it's not faded at all. So we'll come back in. We'll just quickly go over everything that we did. We get a bounding box to create a gradient from the top of our cylinder to the bottom. And then we can comment these. So creates gradient from top to bottom. And then we multiply by a color. Then over this one here is we fade the edges of our cylinder, and then over here we fade by camera distance, and then fade where it intersects with geometry. Cool, so if we save that, that's the material for our beacon. Next we're going to do the material for our arrow. It's very similar, and we'll get into it next. Moving on to the next step, we're going to make the material now for the simple cone. We come in, we create a new material, m underscore cone underscore arrow, and let's open that up. Now it's really similar to what we had before, so we come over and change it to additive, unlit, two-sided. We want to set the color, convert to parameter, we'll just call this color, and the bounding box. Now remember that our cone is pointing down X, so we can take the bounds of our mesh, 0 here and 1 here, down the X. We can put in a power node, and a power will fade based on the exponential, depending also on how close it is to 1. So it sounds like a mouthful, I know, but when we have a gradient, we can demonstrate what it's doing. So we'll plug in this parameter here, and we'll just call this sort of fade exponential. And if we preview this on our box, if we preview it on our box, and we want to make sure we get the right axis here, so we get the red axis because our object is facing down X. And we want to set it to 1. That's why it looks so weird. So if we set it to 1, it's just taking every value and timesing it by itself 1 times, so it's not going to do anything. But if we set it to 2, and now it takes every value and set it, and it's going to times it by itself 2 times. So imagine it's on this side, it's maybe 0.25 here times 0.25. In the middle, it's 0.5 times 0.5, so it's going to bring it down to 0.25, and so on, all the way up to 1. So if we turn this right up, you see it's going to fade off a bit harder. So we can use this to sort of fade out the back half of our arrow. So if we just set it to 3 for now, and we multiply it against our color, we can set again sort of this light bluish color, plug it into our emissive, and then we plug our power into our opacity, and we save that. Save. Then we come in and we just drag it onto our cone. So you can see we've put a bit too much in the power node, so we can bring it down a little bit to maybe even 0.5. So if we go into fractional numbers, 0.5, see it gives us this this nice sort of cone shape, this pointed shape, but it's also fading off at the back, so we don't have that harsh cut off at the edge. But we kind of want to keep it as this arrow, pointing arrow, so it can point the player in the right kind of direction. Before we jump into verse, what we need to do first is actually set these meshes so that they're in objects. So, and they're sort of inside a building prop, so that we can reference them into our devices and we can spawn them as we need them. So we'll just quickly do that now. So we'll go BP underscore what is this, waypoint, and then open it up, and we'll just plug our cylinder mesh in, compile and save, and then we'll plug our material in for the B, so m underscore waypoint, save that. So that's our waypoint mesh as a prop, and then we will do the same for our arrow. So another new prop, and we will call it building prop, and then we'll call it BP underscore arrow. Open that up, again set the static mesh, compile, and then we set the material, so cone arrow. Okay, cool. So I've got that set up, and now we'll jump into the verse bit. Now that we have our objects, our props as props that we can spawn or we can place. So we can save this one, it's just not updating here in the window. And we have our materials and it's all set up. We can jump into the verse part. So we need to right click, come over to our verse explorer, right click, create new verse file, and we'll just go verse device. And we will call this waypoint, way_point system. And create, just create. Save that. And then double click waypoint system. Ooh, and brings up Visual Studio Code. So we can get rid of this. Just type in block first, just so it gets rid of the error. We need to first create an object. So every time a player spawns in, they're going to be assigned this mesh to point to the waypoint system where they are on the waypoint system. It needs to be different for each character, so we need to make one for each character, and we need to update each character separately depending on where they are in the waypoint system. So this tutorial isn't going to be a super in-depth tutorial on how to understand every single concept that I'm going over. I'm going to explain as I go, but I'm not going to get into all of the details of why we're doing it exactly this way or what this code does. But I am going to try and explain as best as I can as I go. So first, before we do anything in the device itself, we need to create an object or a class, a concrete class that we can add to our character. When we spawn our character in, every character is going to be given a waypoint arrow, and they're going to have to track their position in the waypoint system. The first thing we need to do is create a class, so we'll just call it player arrow, and we'll call it class, and we'll make it a concrete class. And remember, this is a class that we can spawn an object of this class and assign it to each character that spawns into the game. We aren't making this class as its own device like we are doing down here. It's separate, it's its own class that we can give its own variables and its own methods inside this class. So first thing we need to do is we need to set the variables. So what do we need to track? First we need to track, okay, which player is this attached to? So we have a variable, var variable current Fort player, and we have to set this as an optional. So an optional is, it can either be nothing or it can be a Fort character, a reference to a player. So we go Fort character equals to false. So you see we get the first error here. It's saying, did you forget to specify using Fort characters? So we can just copy this from here and place it up here using Fortnite/characters. So now you see we have the Fort character type. Next, we need to set what mesh is this character going to be using. So we could have different arrows for different characters if we wanted to. So we can just, but in this tutorial we're just going to use the same for every character. So we go arrow mesh creative prop equals creative underscore prop. So that's the mesh, the arrow that we're going to be using for each character. And then we go variable again, and we go current waypoint of type int, and we set it to 0. So we need to track where the player is, which current waypoint is our system pointing to for this current player. And then lastly, we need var waypoints. So this is the array. So you see we make it an array of creative props. You'll see why eventually. You'll see why because we're using the system down here in our devices. We're going to use an array of creative props, and depending on the order that we add our creative props to the array, is going to set the order in which our characters need to progress through the waypoints. So equals an empty array. So because this is a class, and because we need to set some of these things when we construct this class, we need an initializer. So we go init, and for this initializer, we're going to need to set the current player. We're going to need to set the creative mesh, so the creative prop mesh for our arrow mesh, and we're going to have to pass in the waypoint array so that this character knows about what waypoints it has. So first we go arrow mesh, so we'll call this arrow mesh input of type creative prop asset. Now remember, a creative prop asset is something that hasn't been spawned yet. A creative prop is something that has been spawned. So creative prop asset, we can set it, we're going to set it down here on our device, but a creative prop asset is something we can pick an item or an asset from the library, from the actual content browser, whereas a creative prop is something we pick from inside the level. So the first argument we need is a creative prop asset. The second argument is our player, so we'll go new player of type fort character. Perfect. And then waypoint array of type creative prop. So it's an array of creative props, which is the props that we have placed in the world that we're going to use for our system. And void equals. So the first thing we need to do is we need to set the character of this class that we're instantiating. So we go set current fort player. So we're setting this variable here, and we're setting it to equals option new player. So when we call the initialization function, it's going to feed in a fort character, and then we're going to set it to our variable for this optional fort character. Next, if player is equal to current fort player question mark. So if we have set this player properly, then we can move on into the next part of our code, and we set player to whatever our current fort player is. So we're accessing the optional that we've set here, and we're seeing that it's true now because we've initialized and we've given it a new player, and then we're setting it as player. So this is now instead of an optional type, this is a fort character type. And if it's true, we're going to move forward, and then we're going to go set player position, or let's just go player pos is equal to player dot get transform dot translation. So we're setting our player, we're making a new variable, player position, and we're setting it from our player dot get transform dot translation. And then we want to set the spawned arrow. So our spawned arrow, we want to spawn an arrow for this player, is equal to spawn prop, and then we can get the arrow mesh input. So this one, remember, we're spawning a creative prop asset, and then we want to get the player's position, so we're spawning it on the player. So go player pos, and then we can just use the identity rotation. So we need to specify again that we're using spatial math because we're using rotations now. So just put it in up here, get rid of that. So now we're setting player's position from the player.getTransform.translation, and now we're spawning a prop at the player's position. We're spawning the prop that we're feeding in, the player's position and just its base identity rotation. Next, we need to set the actual, so this is currently spawned a tuple of a creative prop and a spawn prop result. We just need to get the creative prop. So we can go if spawned arrow mesh is equal to spawned arrow. Now you see if we try this, it's going to expected an expression that can fail the if condition because it doesn't know what it's trying to get out of this tuple. So do we need the creative prop? Do we need the result? It doesn't quite know. So what we can do is go 0 question mark. So what we're doing now is we're getting the creative prop out of our spawned arrow object here. So we're getting the creative prop and we're setting it now to just a base creative prop. So then we can now go set arrow mesh equal to spawned arrow mesh, and lastly set waypoints equal to waypoint array. So we're getting from our spawned prop, we're getting the creative prop and we're setting it to our arrow mesh, and we're also setting our waypoint array. So we come in, we set the player, we set the arrow mesh, we set the current waypoint, we set the waypoint array, and that's everything we need to do for initializing the player. So we can come in, we can just put some comments in to make sure that we know what we're doing if we come back and read it again. So we set the current player for this class slash object, and then we set players arrow mesh and set the waypoint array. So we could theoretically even set different waypoints for different characters if we wanted to. Next, the other method that we're going to need for everyone that has an arrow, we're going to need to make sure that the arrow is pointing towards their current waypoint. We couldn't have this as a waypoint that everyone has, you know. Every character needs to have their own waypoint depending on how far along the waypoint system they are, pointing to a different waypoint. So first, we'll make another function. We'll call it update pointer arrow, and void is equal to, cool. So it's our next function. We'll get a little bit of space. We'll just push this down a little bit. So if, again, we'll get this here. So we need to make sure that our player is, so we need to set from our optional, we need to grab our optional, the player that's stored in our optional, and set it to a fort character. Then again, we need to set player position, so we can come back here and go. So we're grabbing the player's position from the player optional. Then we need to do a distance check. Before we do anything else, we need to check, okay, how far away is our player from the current waypoint? So we go if distance from checkpoint, or let's go distance from waypoint instead, makes more sense. And we'll set this as waypoints. So we're accessing the array, and we're accessing the array at our current waypoint. So remember, the current waypoint is which waypoint is our character currently pointing to, like which waypoint in the array is our character needing to access. So we access the waypoint array, then we access whatever index in that array. Then because we're accessing a creative prop, we still need to, but we need to calculate distance, we still need to go dot get transform, and then dot translation. And then we need to minus the player's position and go dot after that length. So I'll explain what we're doing in just a second. So we need to get, again, we need to get the distance to the next waypoint for our character. So we're accessing the waypoint array. We're accessing the waypoint array at whatever current index they are on currently. So which waypoint in the waypoint array is our player currently pointing towards, or our player currently on. We get the transform, because remember it's a creative prop. We get the translation, so where is it in the world? Then we subtract from our player's position, and we get the length of that vector. So that'll just be the distance. How far away in units is our player from the next waypoint? So next we need to set the rotation of our arrow mesh. So we go if arrow rot is equal to make shortest rotation between. So just make sure it's quite a big function. So make shortest rotation between. So now what we need to do, we need to access our arrow mesh, and we're going to rotate it. So first we need to create the rotation. So we're making a rotation between a forward vector in the world. Remember that our mesh is pointing down X, so its vector would be 1, 0, 0. So we go vector 3, and then we use a constructor X equal to 1.0, then y equal to 0.0, and z equal to 0.0. And then we can, I think we don't need this, that's what it's, if starting, the block never starts, okay. So we've made the first part, and then say make shortest rotation, we can take two vectors. So we take our forward vector, which is this here, vector 3, and then for the next vector we need to get the vector from our current player's position to the next waypoint that they're pointing towards. So we need to make a line between where we are and between where our waypoint is. So we can just copy some of this up here. It's the same kind of thing. So we get our waypoint system, and then player pos, and then make unit vector like such. Then what is it complaining about? So we'll just full screen this here, just to make it a bit easier. There you go. So, and then what's the never ends? Sorry, so this is quite a big line here, but I'll explain again what we're doing. So we need to rotate our arrow to point towards the next waypoint in the system. So we go make shortest rotation between, again, a forward vector in the world. So 1 and 0, 0. So this is the forward vector of our mesh, how our mesh is imported. And then we're accessing the waypoint system, current waypoint. So grab the current waypoint from our array, get its transform, its translation, and subtract it. So we create a line between our waypoint and the player's position. And then we make it into a unit vector so we can get the shortest rotation between these two vectors, between our forward vector and the rotation to wherever our waypoint is pointing, so that we can rotate our mesh towards that vector. So the first thing, that's what we're going to do. So we will if arrow mesh, so we can access the arrow mesh because remember it's been initialized in the previous function. Arrow mesh dot teleport to, and then we use brackets or parentheses, player position and arrow rot. And then we just finish that off. So we're getting the player's position. We always want our arrow to be stuck to the player, so we're teleporting it to the player that's in this class, and then we're rotating it towards our next waypoint. Lastly, if we reach our waypoint, we need some way to tell our system that we've reached the waypoint, so we need to point to the next waypoint in the array. So we can go if, it's a lot simpler, if distance from waypoint is less than, let's say, 500 units, then we go we can add one to the next waypoint int here, but what we're going to do is, just for this example, there's lots of ways you can do the waypoint system, like maybe when they reach the last waypoint we could get rid of the arrow, but for this example, when they reach the last waypoint, we're going to make it so that they point back to the start. So we can go next waypoint is equal to mod. So remember modulus, we divide a number and it returns the remainder. Mod current waypoint plus 1. So we're getting our current waypoint, we're adding 1, and then after that we're modding it against our waypoints dot length. So basically all this does is that if we have, say, 4 waypoints in a system, it's going to take our current waypoint, add 1 to it, and then if we reach the 4th waypoint, it's going to, 4 divided by 4 is now going to equal 0. It's going to set it back to 0. 4 mod 4 is going to equal 0. It's going to set it back to 0. So our next waypoint in the system is going to be set back to 0. So it's just going to point back to the start, the very first waypoint. So we can go set current waypoint is equal to next waypoint, because remember this here, we need to wrap it in an if statement because we're getting the array. It could be a failable expression, so we can just set it here, and then we actually set the variable just here. So this is all we're going to need for our player arrow class. Next, we're going to get into building the actual device itself, so we can set up the waypoints and make sure that every time the player spawns in, they get given an arrow. Okay, so now that we've created our class, we need to come down here, and for the next part we actually have to create the device, the stuff that's going to work when we actually start the game. So first we need a couple of variables. We will start off with a map to hold all the different objects and the players that are associated with that object. So we go player arrows, and we go, the key is our player and the object is our player arrow of type map. So when we say here's this certain player, it's going to return the player arrow that we need that's associated with that player. Next we need editable, and we have an arrow mesh of creative prop asset is equal to default creative prop asset. So remember, this is an asset that we can choose from our content browser, and this is the arrow that we're going to be spawning that's going to be pointing our player to the next waypoint. Lastly, we need the array. So we go editable again because we need to edit where our waypoints are. Waypoint array is equal to creative an array of creative props, because these are ones that we have placed in the level that we can put into our array, and depending on the order of the array will depend on where the waypoints point to next. And then we just of type array. The first function we're going to need here is init spawners, which we haven't declared yet, but we need to get every spawner in our level, and when a player spawns we need to assign it a new player arrow, so that every player that comes into our map has an arrow pointing along the waypoint system. So we'll come down here just quickly and we will define init spawners. So we go init spawners, type void is equal to, so we go for spawners, we go get creative objects with tag. And so tags are really helpful for grabbing a whole bunch of objects associated with this tag. So what we can do is we can give a tag to every spawner in the level, and we can subscribe it to the certain event that we need when a player spawns. So we come up here and we just need to set a tag quickly. So we go spawner and then go class and then of type tag. And then it says unknown identifier. Did you forget to specify? We're using tags. So we just copy that and put it up here. So now if we build this verse code down here, so we go build verse code. So it's expecting something. So let's take a look. So we haven't given anything here. So we'll just comment out this line here and just put in a block here for a second. And again, we'll go verse, build verse code. Build now, so we can drag our device, this one here, waypoint system, out into the level, and you see now we can select our arrow mesh and we can select waypoints. So if we delete, so this is just the base mesh here, so we can get rid of that for now, and then we come into our props folder where we have our BP arrow. We can open the full blueprint here, and for some reason it hasn't assigned the, so we'll just remove that for now and put it back on, see if that works. Save that. Cool. And then we can come in and come back to our props here and we can assign. So now our arrow mesh is set to the BP arrow. So we're going to spawn this prop in when we spawn a player. And then our waypoint array, let's put some waypoints in the level. So let's drag out. Again, there's the same issue. For some reason it hasn't assigned the material properly, so we'll just come back into the materials and assign it. Sure, save and compile. So now we can see our waypoints here. We can scale it up a bit. Let's have waypoint 1 here, waypoint 2 here, waypoint 3 here, waypoint 4 maybe over here. So they're named as well, waypoint, waypoint 2, waypoint 3, waypoint 4, and we can put them into our array of waypoints. So we've got here, say, waypoint, waypoint 2, waypoint 3, and waypoint 4. So you see, the order that we put them into this array, 0, 1, 2, 3, depends on, will determine the order of which the player needs to go through the waypoint system. So this is waypoint here, waypoint 0 here, and waypoint 0, waypoint 2, 3, 4. So our players will have to go from here to here to here to here. And then once they get there, it's going to point back to the starting waypoint. So if we come back into the verse code, sorry, again, we needed to, yes, get creative objects with tags. So because we put in our tag up here and we built the verse code, now we can see the objects and we can see the tags in the objects. So we come over to our spawner pads here and we just click this little plus and we go tag. So we got this verse tag markup, so we can assign a tag to this object. So we click down here, you can see it's given us this new tag here, tag spawner, and we can see it's associated spawner with this object, the tag spawner with this object. And we do the same on this here. So we go, so now both of our spawners can be grabbed with the tags in verse code. So if we come back down and we go spawner, and then just like that. So for every object in spawner or spawners, so again, we can get rid of block here. For every spawner in our spawners that's been grabbed with our tags, we assign it to an object, and then we go if spawner equal to player underscore spawner device object. So it's getting the entry from this array. We go spawner dot spawned event dot subscribe, and then we will subscribe on player spawned. Cool. So now it's initialized the spawner so that every time a player spawns, it's going to call this event, which we haven't defined yet. We'll define that down here. But for every spawner now with the tag spawner, it's going to come through and set the subscribe event for this function we're about to define next. So next function is on player spawned. Now remember, for these spawned events, these events usually from our devices, we need to pass in an agent. So we go agent of type agent is equal to if player is equal to player agent. So we're getting a reference to the player from the player map, and then we initialize player. Right, so lastly we need one more function. So if it is a player that's spawned through this spawner, then we need to go init player void equal to if agent is equal to a player. So if we're getting a reference to a player, and we also need the Fortnite character, so we go fort is equal to agent dot get fort character. So this is an actual playable character, someone who is playing in our game, rather than an agent. Remember, can be anyone. It can be a creature, an NPC. A fort player is like a person who is playing our game. Then if existing is equal to player arrows, so we get a reference to the map and we pass in the player. So if the player exists in our map, then we don't need to do anything. We don't need to assign it a mesh or a pointer. Else, then custom player arrow, custom So yes, we initialize, we create a new player arrow object here, assign it to custom player dot init, so we initialize it here. We call the functions to pass it in the arrow mesh, the default character, so the actual player, and the waypoint array. So I'll go through this in a second, and then lastly we assign it to our map. So if set player arrows player is equal to custom player. Cool, so I'll just go over it again. So from the top, we initialize our spawners, then for every spawner that we've tagged with our tag system, we make sure that we're listening for those spawn events. Then when those players spawns, we get the agent, and then with that agent, we run the initialize player function. Then with the initialize player function, if this player is a actual agent, if this agent is an actual player, like a person playing our game, then if this player exists, do nothing. If this player has already spawned and already has an arrow, then we don't need to do anything. But if this player doesn't exist, then we need to create a new arrow object from our class up here, and we need to assign it, initialize it, and assign it to our map with the key, with the player as our key. So we're setting this new player into our map. Next, we're going to come back up, and there's one last thing we need to do. So in the onBegin, we need to get the play space. So we need to get a reference to every, for play space. Every player this is assuming that every player that's playing our game at the moment is going to have a waypoint or an arrow pointing to the waypoint system. Play space. So for play space, unknown identifier, did you forget to specify? So yep, let's make sure we're using the play space module. Come back up here, put it in. Cool, it's gone away. Next then, all players player equal play space dot get players. So what we're doing is setting the play space. So we're getting the play space. So it's getting all of the everything in the play space, and then we're getting all of the players from the play space and putting it into our all players array. And then we loop. So for every player, now we want to update every loop. Every time the game updates, we need to update our player's waypoint so it points in the right direction. So for all players, so for every player in all players in our all players array, we go if the current player arrows, and then player. So we're going to the map again, we're going back to our map, and we're saying if this what's the error saying? So it needs something in the loop and needs a break, but that's okay. But we're going back to our map up here. We're saying for every player in the play space, access our map with our player as the key. So we need to get that object from the map with the player as the key, and then we go current player dot update arrow pointer. So for every player in our play space, we are getting a reference to their arrow, and we're doing the update pointer arrow. So we're running this function for every player every time it loops. So if we come back down, and lastly we need to put in just a sleep here so it doesn't break our game, sleep 0.0, because we want it to update basically every frame 30 times. But we need to make sure we put in a sleep, otherwise the game is just going to crash. And then lastly we go if 0 is greater than 1, which it isn't, we break. Because a loop needs to have a break, but we want, just in this case, just for simplicity's sake, we want to loop this every frame, and we don't really need this loop to break because our players are always going to have a waypoint. So I just want to point out that there's another YouTuber, I think he goes by the name of Mark, he goes by Warforge on YouTube. Most of this code here comes from one of his tutorials. It's a really, really great tutorial. I totally recommend checking it out, and I'll link it in the description below. He's got a lot of really good verse tutorials going over all kinds of cool things. So that's where most of this stuff came from. So yeah, I'll put a link in the description. You can go check him out. Now that we've done all of the code, we can come back into our editor and we'll just take a look, and we'll go build verse. Everything should compile nicely. And again, we've got our arrow mesh here, our waypoint array here, so we can add as many waypoints as we want. So let's just add one more down over here and make sure we plug it in, waypoint 5, and then file, we go save all, and let's jump into the game and give this a go. So I'll stop the video here, and hopefully it should work when we open up the game. Here we are in game, and you can see once we spawned, we've been given this little arrow pointer. Remember that when we enter into a game, when we load up from UEFN, there might be some issues the first time we load in. So if you don't see anything, just stop the game and start the game again, and it should work. I got that issue this time around. But we've got this arrow in front of our character sort of pointing us to the first device. Now if we move over to the first device, once we actually reach the radius, it's going to point us to the next waypoint. So move over to the next waypoint. Once we get just in range, you'll see here, boom, it snaps to the next waypoint. And we go along, boom, snap, next waypoint. And again, snap, next waypoint. And then once we reach this last waypoint, boom, it should snap to the first waypoint again. So I hope this was helpful. Sorry, I know it was a bit of a longer tutorial. I'm going to try and keep them a bit shorter in the future, but I was really excited to show this one, and I learned a lot, and I hope you guys have learned a lot. If you've got any questions, if you've got any comments, if you just want to chat, feel free to jump into the Discord. Now, this code and the assets will be for free on Discord, on our Discord channel. We've put the link below. And I hope you keep an eye out for, we've got a lot more things coming soon, a website coming soon, as well as more tutorials, not just for UEFN, but also for Unreal Engine. If you've got any suggestions from some tutorials you'd really like to see next, even if it's just something small and simple, please let me know. And thank you so much for watching, and this has been Jordan from VFX File.